Hello, Algebra 1 Semester 2 Final Review students. Welcome back, and hopefully you're all tuning in to problem 12 here, at least if you're one of my students, because you might notice on problem 12 it's one of the first, and there aren't too many problems that has a none written right here. And as a reminder, on the past few problems, you've had something written here telling you which lesson we learned this in. We actually never taught this to you. And so there are going to be probably 3 or so questions throughout 53 questions that we just didn't learn this semester. And it was a combination of not having enough time and us really feeling that it didn't fit too well into the lessons. So we're going to go through it right now. Okay? And if you get it, that's awesome. If you want more help, feel free to contact me. And if you're like, this is kind of weird, don't spend too much time on it. It's going to be one problem on your final. One problem is not going to make or break your grade. So here we go. Write a recursive formula for the sequence below, assuming f of 1 is the first term in the sequence. Alright, well the first thing we always do if we get a sequence is we're going to turn this into a table. It gives us a better idea of what's happening. So a table, I mean we're going to have an x, and we're going to have a y, and we have a few numbers. Now these are the outputs, this sequence, so this 3, -6, 12, -24, and 48 are the outputs. Okay, then we need our x's. How do we determine what the inputs are? Well, they told us f of 1 is the first term in the sequence. The first term is the first value in the sequence, that's 3. So my first term is 3. And then a sequence just goes up consecutively. So if this is the first term, this is our second, third, fourth, and fifth. All right, we've got a hard part of the battle out of the way. We have written out the sequence using a table. Next up, we need to understand that recursive formulas have 2 parts to them. A recursive formula always has a part that identifies the first term, and then it has a second part that is going to give you a formula using previous terms. So let's tackle the first term first. Our first term in this sequence, they told us, is 1, 3. However, looking at what's up above, how did they write the first term? Well, they used function notation. They said f of 1, which means the first term, equals, and based on our table, it looks to me like the first term is 3. So we know our recursive formula starts with f of 1 equals 3, which I think quickly eliminates a and b, but still keeps c and d in the running. The second part to this recursive formula notation is they are going to give us, and we're going to need to know a little bit of vocabulary here, but it's not too much. F of n is the term you're, and I'm going to scroll over here, you're looking for. So, for example, if they said, I'll do this right here, if they said, what is the value of f of 6, then that means if you think of a table, we're looking for what is the output for f of 6. And here's the tricky part of recursive stuff. F of n minus 1 is the term 1 before the term you're looking for. So for example, if we were looking for f of 6, then this term would be f of 6 minus 1, which is f of 5. F of 5 is 1 before f of 6. And so this notation can be put together to create a formula. In fact, let's look at the pattern up above, and then we can finish off with the formula. If I wanted to find this term, and I knew the ones before it, could I? Well, keep asking yourself that question. Could you have found 48 if you knew -24? Could you have found -24 if you knew 12? Could you have found 12 if you knew -6? And starting at the beginning, maybe another way to phrase this is, what's the relationship to take you from 3 to -6? hopefully you can see you're multiplying by -2 every time, aren't you? So, if you wanted to get f of 6, what would you do to the term right before it? Well, we could say that f of 6 is the term right before it, f of 5, times -2. We just multiply by -2, and that would get us to the next term, right? And the way that we write that using our function notation is that f of n, the term you're interested in, is found by looking at the term 1 before and multiplying by -2. This is called a recursive formula. In order to find a current term, you look at a previous term and figure out what the pattern is. And by looking at that, we should be able to see that our answer here is C. That's it. Hopefully that is helpful. Hopefully you slam dunk the question like this on your actual final, because it's no harder than that. Identify the first term. This notation will stay the same, and the question is just what's the pattern every time. Again, if you want more practice, we have plenty of more practice on this. We just didn't have time to fit it into the semester. So thanks for your attention, and keep up the great work for preparing for that semester 2 final.